Hi there. Once I heard about wave-particle duality, I thought it was something weird, so I decided to figure out what it's all about. But before we examine this question, we should understand the differences between a wave and a particle. Particle is a small, localized object, like this ball. Meanwhile, wave transfers energy from one place to another through oscillation.
Waves transmit energy through water, causing it to move in circular motion. Most common are surface waves, caused by wind blowing along the air-water interface, creating a disturbance that steadily builds as wind continues to blow. Little ducks can make a wave either, but it's much weaker. As you can see, the differences between a wave and a particle are way too big.
But before, a bit of history.
In 19th century, Thomas Young, English scientist, proposed that light may have properties of a wave. Later, in 20th century, Albert Einstein proposed that light consists of units of energy, known as photons. That was later confirmed by the photoelectric effect experiment. This dual nature of light became known as a wave-particle duality. In a few years, Louis de Broglie extended the wave-particle duality to electrons. He argued that electrons not only act as particles, but can also act as waves, and demonstrated it experimentally in 1927. He received a Nobel Prize in 1929 for his research that marked the start of the development of wave mechanics. In order to prove his statement, Louis de Broglie with a group of scientists ran an experiment using an electron gun. At first, they shot electrons through a special screen with a single slit, and electrons landed on a second screen forming a single band picture, so the electrons behaved like regular particles. Then, they shot electrons through two slits, but the picture on the screen showed the interference pattern. Electrons behave like waves. They thought that these electrons bounce from each other to create such a pattern. In order to exclude such possibility, they decided to shoot electrons one by one, so that they couldn't interact with each other. But after an hour or two of shooting, the same interference pattern appeared. The possible conclusion was that a single electron flies as a normal particle but becomes a wave of potentials as it approaches two slits, goes through both slits and interferes with itself, and then hits the screen. But then, they decided to track which slit this electron goes through. They placed a tracking device at one of the slits and started shooting electrons again. But surprisingly, electrons started behaving like normal particles, landing on the screen to make a picture of two bands. The very measurement of the experiment made electrons behave differently, as if they knew that scientists are watching them. They concluded that matter in quantum world can act both as a wave and a particle, based on different conditions. But hey, science should be fun, so we decided to make a reconstruction of their experiment with handy stuff. We will use screen, box with two slits, camera, and paintball marker. Let's begin. We will shoot paintballs on a screen through two slits and see what happens.
We shot multiple paintballs on a screen, and in our non-quantum world, they behave like normal particles, just smashed on the screen. Or maybe that happened because I've been watching them so closely. Well, at least we had some fun. What intrigues me the most in wave-particle duality is that the electron, even though it's a tiny piece of inanimate matter, seems to make a conscious decision, according to presence or absence of the observer. I believe that people of my generation will solve this mystery, and hopefully some of them will be inspired by this video. Thank you for watching, and good luck to all the participants of Breakthrough Journey Challenge.